To welcome you to the webinar and share about MEOPAR and our role in the Antarctic expedition aboard the HMCS Margaret Brooke, we'll have Jamie Snook, MEOPAR's Executive Director, welcome you.
Thank you, Rosie, and welcome everyone. It's nice to meet, or I guess interacting with a lot of you for the first time. And if there's one thing that I'd like for people to learn and understand about MEOPAR is that as a network and a nonprofit, we're all about coordination and collaboration and trying to connect as many different sectors and disciplines and people as possible. And we were very fortunate this past winter season to be a part of a broader project that had many different partners, and excited to get a behind the scenes firsthand perspective today that everyone will get an opportunity to learn from. But I will say this is the type of project that we dream of and would hope to see a lot more collaboration like this in the future. And just to give a short thank you as well to our funder, which is the Department of Innovation, Science and Economic Development Canada, and the Strategic Science Fund, which has certainly helped enable this and make it possible. And with that, I'll pass it back to Rosie, and hope everybody enjoys the webinar. Thank you.
Thank you, Jamie. We're thrilled to have Susan joining us on this webinar today. So she is CBC News' first international climate correspondent and reporting on the global impacts of climate change and energy. She's a veteran journalist, has covered major international events across 30 countries, including conflict zones, global crises, and climate summits. She brings a deep expertise in storytelling from her work in Europe, the Middle East, and North America, and she continues to lead reporting on the urgent global climate conversations. She joined the expedition to tell the story of this inaugural collaboration and the first of its kind Canadian expedition between scientists and the Royal Canadian Navy in Antarctica. So she will share about what that process looked like.
All right, over to me. Carrying on from Jamie's opening remarks, it was also a collaboration that I dreamed of, this Antarctica expedition. I lived on the Navy ship, HMCS Margaret Brooke, with Brent and 93 other people for a month. Eating, sleeping, relaxing, working a lot together, separated only by maybe, I don't know, 10 or 20 feet down the hall, our office space. So we got to know each other quite a lot more than when we started. We didn't know each other at all. I'm going to do two things. I'm going to walk you through a little bit about how this happened. My role here is really to help educate and to help advise, really, how you can turn science into stories that attract a wide audience. I'm not a science journalist. I'm not even a climate journalist by reputation or by education, but I am a longtime journalist. And I would say that two things: I'm a storyteller, veteran storyteller, and also a translator. And what that means is my job is to translate complex subjects, whatever they are, into accessible stories that will ignite, maybe infuriate, draw attention to whatever I'm working on. So the Antarctic expedition, as we all know, was all about science. So my job was to make the science relatable, and it was not easy. I'm going to tell you a little bit about that for a few minutes. I'm also going to show you a 10-minute video, which seems long, but I think it's pretty engaging, about the science that happened on this expedition, because what you'll see is how we took the very important work that the 15 Canadian scientists were doing on this expedition and translated into stories. In this case, a long story that we've pieced together, but in most cases, shorter stories or different platforms of media, be it radio interviews, news in the morning, live interviews. I know some of the scientists did some lives for various CBC outlets across the country. A little bit of background on how it happened. What I know is that it came together more than a year ago when the Vice Admiral of the Canadian Navy, the commander of the Navy, Angus Topshee, was at a meeting, I believe in Brazil, but speaking to Brazilian Navy personnel, regardless, his counterparts. And he developed an idea that he wanted to do some outreach and building bridges with South American navies. Go south during our winter when this particular ship can't go up north and cut through the heavy ice in the Arctic. So it went south to the Antarctic, which is in the summer months there. Angus Topshee quickly found out, I don't know how, that you can't take a military vessel into Antarctic waters as per the treaty unless you have a science mission. So the word went out. Brent may know more about this, or Jamie, but essentially a team of 15 Canadian scientists was assembled and came up with plans to do work aboard the vessel. It took a lot of preparation, a lot of jury rigging of the ship to become a research vessel, and Brent, I hope we'll talk about that. The planning time was short, I think, for everybody except maybe the Navy. I believe the science team started in the summer. We can hear more about that. We got involved in November. I had been looking around for an opportunity to do something big on oceans, as they are such a barometer of climate, and we could see that over the last year. So this was in our mind. We had tried to go to Antarctica with the Spanish a year ago. Anyway, in November, I found out there was what I call a perfect, not a storm, a perfect scenario for the Canadian Broadcasting Corporation to be involved. You had a Canadian naval ship, you had top Canadian polar and climate scientists, and we were the Canadian Broadcasting Company, and we had an opportunity to maybe collaborate together. But what that meant effectively was you're taking three cultures. You're taking the military culture, which is strong, the media culture, which is unpredictable, and the scientific culture, which is rooted in data and experimentation and collaboration. And you put them all on a floating village for a month. And I think all of us had a little bit of question marks about how would this all turn out. It was a real experiment on so many fronts, which made it exciting for everybody involved. What were the selling points then? Well, the selling points for the Navy, because it wasn't easy for the Navy to say, sure, we're going to have scientists. They got that sorted. And then, sure, we're going to have a media team, sometimes the enemy, observing us 24/7 for 32 days on our voyage. So somewhere along the line, I talked to a few people in the Department of Defense whom I knew from many other opportunities. And I pitched that we could do this and that it would be good for everyone. Someone agreed at the highest level and said, yes, we will try to make this happen. Very little space on board. The scientists had already secured the bunks that they could release to the science team. So they basically said, yes, you can come, but you have to sleep in a closet. And we kind of looked at the picture of the closet and went, okay. But there were real concerns about space. For us, this was a real opportunity to do what we call access journalism, where we had access to a science team as they're working to try to decode and make stories out of how they worked. For the Navy, I think it was an opportunity to show Canadians what the Navy can do, and in this case, in a non-conflict situation, so that there wasn't the risk of the normal risks and stress and tension when I've worked with the military before, like in Afghanistan, where there's an active war going on. This was an opportunity to showcase what the Navy can do as a Navy, but also expanding their role in this first ever collaboration with Canadian science team in Antarctica. So they were stretching their wings. They could showcase that. And I think everybody there was probably hoping it all went well, which it did. Just want to talk for a few more minutes about what the challenges for our team was, and I'm sure Brent has a similar list. The challenges were, as I've mentioned, translating science. I mean, our mandate is we need scenes and access and decoding, as I said, complicated science. There was a challenge, of course, with science because the work is incremental. It adds to data that's already out there, or a body of research, but there were no conclusions. So my desk would be saying, okay, what are they doing? I described that. What did they find out? Well, what they found out will come. But that's a hard concept for a news organization whose attention span is about 24 hours. So I had to really work hard to convince them that we could turn these into compelling stories. I had elbows up in the spring, a different kind of elbows up than those us Canadians back in Canada at the time, but I had elbows up trying to get my desk to agree to get as much of our content on as possible. Breaking through the time period, and for any of you who are interested in more media storytelling, the news cycle is key. We had Trump, we had tariffs, we had a new leadership race, we had chaos, we had confusion, worry, all that happening at the same time we were in Antarctica. It was blissfully peaceful where we were, but I had to break through that news cycle to get science in Antarctic on our news platforms. Time, always an issue. Typically a news story is 2 minutes. We often do longer stories, at least I do, but it's rarer, and 2 minutes to tell a complicated science story, it's near impossible. I think we cracked it, but it's always our challenge. It's not ideal, but it's the art of the possible, just like politics. Access, I've talked about that. Storytelling means access, finding scenes and finding characters. It's about drama, it's about humanity, it's about exploration. We had all of those things. We didn't have a headline. You know, Canadian scientists discover the glacier is going to fall off the earth by X date. And so we had to come up with ways of pushing it along. How are we helping develop the idea of climate change and in our world? And then weather. I'm sure Brent will talk about this. It's so unpredictable. I mean, we would all have a plan when we went to bed at 10 o'clock at night, and by 6 in the morning it had changed. And then it changed again at noon, and then it changed at 5 o'clock. And what that meant was the Navy was providing resources for the science team to go and do their work, which meant lowering boats into a choppy sea, which meant lowering big equipment, in gale force winds. We always had to be flex. We learned about flex time on the Navy ship, and I think we all adapted really, really well. The Navy could have been a challenge, in my estimation. It wasn't. The Navy was extremely collaborative, helpful, cooperative. They gave us really unrestricted access to the places we needed, and they were always trying to help us do our job better. We broadcast live from the ship using a satellite, a Starlink that the Navy installed on the very top of the ship. Well, it turns out our Starlink from CBC, of course, could only withstand gale winds of 40 knots. And when it was more than that, the engineer on the Navy ship would come down and say, "Ma'am, yes, Jimmy, it's going to be gale force winds tonight. We're going to have to take your satellite down." And they would. They did that 3 or 4 times. So it was really I felt at the end, I think as all of us did, it was a mission to get this important work done. Everybody did their jobs, and that was really, really wonderful. With that, I'm going to throw to some video so you can see how we translated and transcoded science. And then after that, Brent and I are going to have a good chat. I think we're going to get into that video right away.
Welcome back to CBC in Antarctica. It took almost a week to get from the bottom of Chile across the Drake Passage and into Antarctica. But the science started right away, and they learned that it wasn't always smooth sailing. Every day, suit up,
Get me a little further.
load up.
Well, I've got 5 bottles, 5 glaciers.
The scientists are headed out to the glaciers, lowered in a Navy boat turned research craft, to measure what's changing in the ocean at the bottom of the world. We're going with them. Antarctica helps regulate the global climate, but sea ice is melting to near record lows. February had abnormally warm temperatures, which over time affects everything in the ocean ecology.
We've seen a ton of penguins today. Hopefully there'll be some penguin DNA in there, some whale DNA.
Jenny Tolman is capturing DNA in water samples, but her expertise is the smallest of organisms.
Microbes are the little engines of the ocean. They're also the things that they respond the most quickly to change, and the poles are a very rapidly changing place.
But collecting samples can be tricky work. Tia Anderlini is studying trace metals, reaching out to scoop up seawater.
I was using a really long pole, basically to avoid contamination from the boat itself.
Woohoo! And at sea, things just happen.
Ooh, I dropped it.
A plastic lid slipped into the ocean.
Can you look over and see if there's a cap floating under the boat?
But within minutes,
Retreat!
it's been recovered. Glaciers are retreating in the Antarctic Peninsula more rapidly than before.
The depth is 51 meters.
One way to measure what's going on is grabbing sediment from the sea floor. Jeremy Bentley lets down a large claw to the depths and then hand over hand hauls it back up to deliver a muddy mass. There are clues here, and with deeper cores, about glacial history,
We're looking at changes over time.
including human imprint, like any evidence of microplastics.
It's like a Christmas day for me with a good sediment sample.
A good bit of mud.
Yes.
Most of the samples will go back to Canada to analyze and share. There's more ambition than time. It's so rare to get here. The challenge is worth it.
It's a great day for samples from glaciers from here.
You got everybody?
Here.
Day's end, it's back to the mother ship with a bit of Antarctic scientific treasure. But their day isn't over yet. As night falls in Antarctica, the HMCS Margaret Brooke darkens, switching to all red light.
Slewing in
There's still work to do.
at the water line.
On the quarterdeck, a hive of discovery.
Yeah, let's bring it on board.
A long net pulled out of the ocean and hosed down carries small organisms
We're good.
which play a vital role.
So just seeing here mostly voracious filter feeders. They eat particles, organic matter that's in the water column, and then they poop it out. So
They'll be examining these salps for contaminants.
Here, this is a solitary form. And these
The
guys.
scientists are educating the Navy's top commander, Vice Admiral Angus Topshee, on oceanography.
You'll have to forgive my science as well. I was an arts major, so anything I say the Navy has taught me.
I'll stop, please.
Brent Else is sampling the Southern Ocean water using a CTD Lars, custom built in Canada. It plunges deep into the ocean under high pressure to capture water at different depths. Here, as deep as a kilometer.
Roger, holding.
The rosette, as it's called, comes up brimming with water.
And then we get a cap on right away.
For the average layperson, you know, water is water. So you've got a whole ocean out there. You're collecting water and you're putting it in all these different containers. Why?
Well, because water isn't just water. In an ocean like this, there's lots of different water masses. There's lots of different types of water at different levels in the ocean.
Are you on 10 too, Celine?
I mostly measure dissolved carbon dioxide, and I'm interested in how carbon dioxide moves from the atmosphere into the ocean and then moves deep down in the ocean where it is sequestered for hundreds or thousands of years.
Bottle 5 has nutrients.
It's liquid gold for these scientists. Everyone wants a bit of it for their own investigations.
We all work together, we get the rosette train faster so we can go back in. And everybody gets to bed a little sooner.
The cold water in the Southern Ocean around Antarctica is a huge carbon sink. absorbing a lot of the carbon dioxide emissions we put into the atmosphere. But as the sea surface warms, that could change.
As the oceans warm, as circulation patterns change, it's expected that that ocean carbon sink will slow down over time. And the polar regions are the areas where those carbon sinks are most important.
For the last 3 weeks, 15 scientists from across Canada have turned the Navy vessel into a research ship.
50 meters.
Working with the Navy crew to maneuver the boats.
They can tie it off stern as well.
Operate the crane, lower the winch, and generally assist them daily to gather up samples.
The time's 19:18 and we are at 147 feet.
In this extreme environment, there's been a lot of learning.
Good to go, you have permission to launch.
This team is trying to haul up mud from the ocean floor, using what looks like a torpedo, weighted to plunge it into the seabed with force.
150.
Jeremy Bentley is on the winch.
200.
The seabed sediment will tell them a story.
Coming back in.
It definitely looks more disturbed at the top than the other one, but we'll keep this one just in case it's the best in the end.
Sophia Johannesson will slice up the cores to analyze.
Whatever happens in the surface above, the particles sink down and they build up layers in the mud, the newer ones on top of the older ones, and we can read that history back through time and we can learn from it. It's been pretty hectic. The first day was a bit of a disaster for field work. Pretty much everything went wrong that could go wrong.
They adjusted and managed to fill a fridge full of samples. Turns out all mud doesn't look the same.
If we take this core out, for example,
and it's different ages.
This is a section that's about 1.5 meters long, and so represents about probably 1,000 years of history at the bottom of the ocean.
1,000 years of sediment here.
Probably something like that. You can see that the sediment is much darker.
Alex Normando and Karen Douglas will send these samples back to Halifax to be x-rayed.
We use an X-ray, yeah. It helps to enhance areas of the core that are denser than others.
We can get a clearer pictures of the past climate change and then being able to predict what's going to happen in the next 50 to 100 years here in Antarctica.
Antarctica is a coveted lab. One of the few places in the world which has mostly escaped a heavy human footprint. Sandy Steffen and Jeff Stuffel are sampling snow for what shouldn't be here. Contaminants like mercury deposits and microplastics.
They can travel long distances from source regions into remote areas like the Antarctic. So we're looking for very minuscule fiber like microplastics to see where they've come from.
Do you think they are here?
Absolutely. Mercury is a problem because once it gets into the ecosystem, it can turn into a very nasty toxic form.
They'll keep the snow frozen until it gets back to Canada for many researchers to analyze what's hidden inside.
When I talk to people about the impact of climate change on things, they just consider warming. And they consider, like the ice is melting and all this. And I said, yes, but what happens when the ice melts?
Yeah, so there's a bit of a clearance too that's closer to that iceberg on the other side.
The HMCS Margaret Brooke carried the science team well past the Antarctic Circle.
Between the two mountains, that's our channel.
Breaking ice to get through.
Okay, roger.
Revealing the powerful icy contours of Antarctica. While sailing to the most southerly point the Canadian Navy has ever been.
Port 15.
With the field work paused for now.
Slow ahead both engines.
There's time for some reflection.
One of my goals in coming here was to make the Navy fall in love with science so that they would just want to, keep working with us and keep going on adventures with us. and we've had nothing but support, and that's great.
As Mission Antarctica continues its journey.
All right, that's a little sample of our work. I want to throw it over to Brent really quick here because I'm a few minutes over. Just to say that we are going to have a special on the whole Antarctic mission, including those science stories, more science stories, plus some stories about ice breaking, and that's coming up next week. First week in June, and we'll be doing lots of promotion about that. So I have lots of thoughts about Brent watching this again, but there's the links when it's going to be on. It's an hour special, and feel free to dip in and watch the rest of it. But I'm going to throw this back to Brent.
Great.
Yeah. Very quickly, just to introduce you, Brent.
Sure.
Brent is a professor in geography at the University of Calgary, and he teaches environmental science there, including oceanography, meteorology, and hydrology. And the Canadian Arctic is his primary geographic focus, but evidently there's a lot of overlap between the two poles. So he was able to apply a lot of this expertise on the Antarctic expedition. He's led major oceanographic expeditions and smaller community-based field campaigns. As co-scientific director of MEOPAR, he's focused on innovative approaches for researchers, access ships, and other marine research infrastructure. And he was able to apply that to the success of the Antarctic expedition, as you got to see in the video. So with that, I'll give you the floor.
Yeah, great. Thanks, Susan. That was great to see all of those videos. You know, one thing that always strikes me is when you're on an expedition like that, that's your entire life for an entire month. And then it's strange how quickly things go back to normal when you get home. And to see a video like that, really see all the people, see all the things that we did, it really sort of brings me back to that place that we were. So that's really cool. And it's neat to have an opportunity to chat with you again. And I think there's a lot of things that we could talk about. But one thing that sort of stuck out to me when you were introducing yourself there, you introduced yourself as a storyteller and a translator. And I think that's one of the first things you said to me as well when we met on the ship. And I think that really comes through there. And it's really interesting. I think I think there was a lot of good work that the science team and the reporting team did together. But I felt like if there was ever sort of one area where there was a little bit of friction, it would have been around, you always sort of pushing us to explain things like, what are you worried about? Why are these things important? Trying to sort of draw out some sort of personal side of things. And I feel like as scientists, we're often trained to avoid doing that. And, you wanted to tell exciting stories, and we just wanted to tell you boring stories. And so I'm just kind of curious, from your perspective, how that went. And I could comment a little bit in a minute about what I think the outcome was. But, from your side of things, how hard was it to draw those things out of us?
It was super hard, but mostly because I came with very little knowledge. As I said, I'm not an oceanographer. And I applaud you, Brent, for not saying, when I asked you, water's water, isn't it? Not saying, are you an idiot? Because your response kind of indicated, and I thought, well, I have to ask these questions because my audience knows nothing about carbon dioxide. Honestly, they come to this cold. And so for some who are listening to this, you must be thinking, oh, this is such basic stuff. Like, of course, the ocean's warming. I'm telling you, what I'm trying to do is break through the ignorance about our world and try to make people understand. So it was hard only because we were dealing with a lot of science, 15 scientists, but a lot of people had different projects, and maybe you can talk a little bit about that. So I was trying to catch up all the time. Like, what are you doing? I had no idea what a sediment core was. Zero before I got on that ship. So I had a huge ramp to climb in terms of learning, and then learning to translating, and then making television. So I found little bit by little bit, it got a lot a lot easier to pull things out of you all who understood what I was trying to do and never once said no. So I appreciate that.
Yeah. Okay. Appreciate that. Yeah. I think one of the main points of feedback that I got from family and friends who were watching the coverage as we went along, which by the way was a really cool thing. It was neat to be able to sort of feel like our family and friends were along on the expedition with us. But one of the things that they really said to me is that they felt like they got to know us well. They felt like our personalities really came through. They sort of said, wow, it really made it seem like, scientists on this ship were real people. And a couple of people said, oh, I didn't know that you enjoyed your job that much. So I think you did do a good job of sort of pulling those things out of us, and, making an exciting story, even though, as you said, a lot of the scientific results are quite a ways down the road. So, that from my perspective, it seemed like that you accomplished your goals of telling some interesting and engaging stories, and sneaking a little bit of science in there too.
I'm curious from you, because you all did such a lot of work to get the ship retrofitted. And right. Then in the first few days, I knew, of course, it's going to be a bit of chaos trying to get everyone up to speed, including the Navy, who was helping you, how to do that. So tell us a little bit about that work.
Yeah, it was a lot of work done on a short time frame. You mentioned your time frame of sort of getting really involved in November. For a lot of us on the science side, it wasn't a lot longer than that. We sort of started to hear about it in the summer, but it didn't really become real until, I don't know, probably October or something like that. So it was a lot. It was quite a bit of, there was quite a rush to get things together. And I think, one of the key things here is that there were 15 people on board that boat, but there might have been 100 people behind the scenes that worked to get equipment on board, and even helped us when we were on board. When we did run into problems, we were phoning home all the time, talking to technicians that were on shore, trying to help out with bits and pieces like that. So it was a big job, and like you said too, you mentioned always being a bit concerned about how it would be to work with the Navy. would it be a big challenge? And for us, from the research side of things, I think we've all been on ships in the past, whether they're oftentimes we charter ships from the private industry, and then we're on a ship and we're doing they're doing something that they've never done before. And in a lot of cases, the response from a crew to something like that is to be quite resistive, to say, oh, we don't really want to do that. Even in situations where we're paying to be on a ship, people get nervous, and they don't really, there's a tendency to sort of shy away from those new and challenging things. And like you said, same perspective for us. The Navy was amazing, and every time we came up against a problem, that would have been an opportunity for the Navy to maybe say, okay, well, that's difficult. Maybe we just shouldn't do that. Or an opportunity to say, well, that's a problem. Let's see if we can solve that together. And what we found every time was the Navy saying, okay, that's a problem. Let's find a way to solve that. So I think those were the things that made this really successful. And when you layer on the short period of time that we had to pull it all together, being able to respond quickly being willing to solve problems is really important, because there's always going to be problems. And in this case, there's even more risk of that sort of thing happening. So, but yeah, I was curious too on your side, the short planning. Maybe that's a little bit more common in your world. Are you a bit more prepared to rush out to the field on short notice and get a story, or was it a big challenge?
Yeah, of course we are. It can happen in an afternoon, but this was different. I mean, my main challenge, drawing back the curtain a bit on all our organizations, is I had to pitch to the Navy, pitch to the science team, and then pitch to my own organization. And I was doing it basically myself. So everybody had to agree. And I kept pushing them. We need to know. I got to get a cameraman for a month. wrestle him away from his family. He doesn't know anything about this. So there was one meeting I remember in late January. We were leaving February 20th, where I said to a team, I said, I need to know. I need to know now. The Navy, the science team has said, okay. The Navy has said, okay. And I hadn't got a go yet. And I said, you guys, if this is a no after all this work, you're phoning the Navy, because I'm not doing it, because I think this is a slam dunk. And of course it was. I mean, the content, everybody was so happy with everything. So yes, it was challenging. I did want to ask you, Brent, a little bit about the science that you were able to do, because I never actually got to this stage in our reporting. Was it enough for the place you were? It's never enough for a scientist, I understand, but did you feel like you, as a unit, you did accomplish some significant science goals in that region?
Yes, yeah, we definitely did. And I think, we we sort of hate to do this, but we do sort of measure our success by the number of papers that we think we can write about this, and that's not the best way to measure the success of anything, but it is important because when you have a paper, when you write a peer-reviewed paper, you're reporting your results, and you're taking that important step of communicating what you did to the scientific community. And I think we feel quite confident that we'll have several papers to write about here. We'll definitely be able to contribute some new knowledge about this particular region, about some specific oceanography of the region, some of the specific parameters that we were measuring haven't been measured there before. So there will definitely be some positive results that come out of this. So yeah, I think by our common metrics of a scientific expedition, we'll be able to say that it's successful. But the other piece of success, and you sort of mentioned the challenge for you is was that you wanted to be able to report on outcomes, and of course the scientific outcomes will be down the road. But a key outcome for us was, for me particularly, was that we could do this kind of work on this particular class of ship in a challenging environment too, because I mean we could have taken one of these ships and sailed around Bedford Basin in Halifax or whatever, and proved that we could collect some samples and do some science off a ship like that. But that was really unknown going into this. This class of ship is very new. It's only been in the water for 4 years or so, and there haven't been, that I know of, really any opportunities for scientists to try to work on them. And so that was a big unknown, but there's a big potential payoff there because, these ships will be around hopefully for a long time. And my main goal, I mean, as I mentioned, I guess as I famously said, was to make the Navy fall in love with science, but also just to prove that, to show that we could do something useful on these ships. And we did that. And I think that your reporting captured that really well. And so, I would say that you definitely do have an outcome there to report on, which is that we did it. we managed to go there and collect samples and do science.
Yeah. We did do it collectively. Do you get a sense, it's so funny sharing some of the other things that you and I both experienced, when the commander of the Royal Canadian Navy came on the ship, I know that all of you were trying to get his ear to say, hey, this is working really well, let's do it again. And Tom James, the chief scientist, was pulling him over on the deck in the dark saying, hey, next time, can we have a helicopter? I was laughing listening to this. I don't think they've committed exactly, but they did see that was a possible outreach of their mission on that ship. I don't think it's going to happen every year, especially in Antarctica, but I wonder, do you get a sense that there could be future collaboration here?
Yes, I'm very positive. I'm very confident that we will be able to build on this. This is going to be the The challenge, though, now going forward is to make sure that we have some conversations with the Navy and sort of debrief on the mission and, where were the successes, where were the challenges. But what I will say is that, so you sort of characterized this properly, Susan. When we were first planning this mission and the idea of bringing reporters on board came up, we on the science side were not in favor of doing that. I think you know that. And really it just boiled down to, we were really nervous that it wouldn't go well, and that, the only story that out of this would be of this colossal failure. We should have perhaps had a bit more confidence in ourselves and a bit more confidence in our Navy colleagues. But I think, so you were there, you did all of this. And I think what that's really helped us is to get the message out that it was successful. And I think that, I can't speak exactly to what would have made this a successful mission for the Navy, but I'm sure that the chance to showcase what they can do, what they are doing, what kind of people work for them. I think that has to be a positive. And so, in the end, I think this was nothing but added value to the main goals that we had, that I had, which was really to, for everybody to walk away from this saying, okay, that worked. And if you can do that, then the chances of people saying, okay, let's do it again is much higher. So I think in the end, having you there really advanced those goals, even though we admit to being nervous from the get-go.
Normal.
That's normal. Okay. Awesome. Good.
Do we want to throw it to questions, or we can continue to chat? For sure, we've got lots to talk about.
Yeah, we're kind of at that time. Maybe. Did we get any questions? Are you saying something, Rosie? I'm not hearing you.
So,
are you hearing her, Susan?
No, I'm not. While Rosie figures that out.
Okay, cool.
Interrupt me at any time. We'll just keep going here, and Rosie, you can jump in if there are questions.
Can you hear me?
Yes, I can.
Okay, what happened there? I was just saying, if there was a final thought that you wanted to reflect on, we can make time for that. If not, we can pop to the questions and have members attending the webinar jump in there.
I'm good to go with questions.
Okay,
yeah, me too.
We already have a question from Mike Gregory. He's saying, what is in the pipeline for CBC coverage? Anything beyond the June special?
Mike, the June special is a huge accomplishment. We're going to have an hour content on CBC platforms. It'll be what we call evergreen, so it'll live on GEM for the summer. We're trying a few other ideas, but I'm thrilled that this is going to get more eyeballs, as we call it, outcomes, as Brent calls it. It's going to get more coverage. So, and we're going to put all of our stuff, including the stories we did on politics, on diplomacy, on SEALs, and other things. So, yes, and I can see the questions too. So I'll just plow on here, Jonathan. That's a very good question, and that is something we hope to explore. The question is about plans to cover the results. Planning publications, they will take time. Will they get any coverage of that? That's a fair question, and yes, we hope to. And the great thing about that is that oftentimes scientific papers are exactly that, paper. I'm a broadcast journalist for the most part, so paper is hard to cover. But we have all this amazing footage now of what they did to get those results. So again, it just pays off down the line. We're hoping, I think, Brent, when we left each other, we were talking collectively about possibly something in a December conference in Calgary, a science conference, maybe something then, and certainly down the line. But you can be sure that we'll be looking for results, for outcomes to make other stories about what happened down there.
Yeah, and Susan, as you know, we spoke to a few other journalists along the way too, who probably wouldn't have any idea that was just going on if it weren't for your coverage. But it was interesting because a lot of people that I spoke with just in these little, like 2 or 3 minute morning show things, everybody sort of said to me, can we follow up with you when you have some results? And so it probably reflects, your point about wanting to have that part of the story as well. So, it'll be interesting to see if those were genuine bits of interest. But we'll see. I've got a list. I'll reach out to those people and see if they genuinely do want to know when the results come out. But I have a feeling they might not have the same interest as you do with, like you said, the ability to attach some imagery and a bit more depth to them.
Yeah. When I was a young journalist, Brent, I remember one of my first ever jobs was having to do a story on the crow rate in the prairies where I grew up. I don't know if anybody knows what the crow rate is. It's a rate about grain. It's a calculation about grain. I knew nothing about the crow rate. But I learned something. I called up a guy on a Sunday. He was the head of the grain board or something, and I didn't know what I was talking about. He was so kind, and he helped explain things to me. And speaking to your nervousness about having journalists on board, I always tell people, you're the experts. I'm just trying to learn from you and then decode what you're doing in terms of scientific results. We're not talking about, politics. And so, find the people that you trust in the media community to interpret your results in the right way. Follow up with them. Try to engage them, try to understand that there's, success means you need a news peg. It needs to be timely. Like today we had the results, like give us 2 days notice of when your papers are going to come out so that we can, absorb them, figure them out. Understand that we'll want something on camera. We'll want people to quote, things like that. So we can learn about each other's profession that way and take some of the mystery and the nervousness out of the arrangement. Because, yeah, I think it's really super valuable that Canadians see the work that Canada is doing. And you said in one of our interviews, which I used in other stories, that I don't think people understand this whole idea of us being an Arctic expert nation. We are experts in the Arctic. You are. We don't say that. We don't shout that enough. I mean, goodness, look at all the Arctic issues right now. Greenland, Arctic sovereignty, Arctic security, Antarctic climate warming, Antarctic security, which we were exploring along the edges on our trip there. And that's certainly what the Navy was doing. So we should be, as you say, we should be leading this.
Yeah, and that sort of leads into a question that's in the chat there from Patrick, who's somebody that I know. He's a former student of mine, asking about what this mission means to Canadian science on the world stage, with us not really being known for big Antarctic expeditions. Yeah, I think that's really important, Patrick. And it was actually something that I wasn't really thinking about too much until we left, until we were on the ship. And then, it sort of, the whole expedition was happening as Susan mentioned, around a backdrop of tariffs and Trump and all of this sort of stuff. And I think a little bit of a swell in sort of national pride. And I felt like the mission was kind of timely in that context. I did feel fairly proud that this was a entirely Canadian expedition. And so, I can't say for sure if it's raised our profile on the international stage, but certainly, and here again is a piece where Susan's work was really helpful. It certainly raised the profile of polar science within Canada, and I hope created some sense that we are capable of mounting, some pretty significant scientific expeditions. So that was a really neat piece of it.
I'm just going to jump in here. Howard, you had a question about the Navy can supply a drone instead of a helicopter and the small yellow boat. What was that used for? Interestingly, Howard, is that the Navy's not allowed to have a drone in those waters. There was drone viz, but it wasn't done by the Navy, the Canadian Navy. And it's because of the Antarctic Treaty, where you can't use drones, and even if they are employed for scientific missions by a military. At least that's what the rules are. And there's a whole story in our special about the Antarctic Treaty, so you can see more. You can also see a whole story on the Little Yellow Boat, which was a unmanned vessel that was from the University of New Brunswick. We did a story on that too. It was really interesting. Kevin was a wonderful ambassador for that vehicle, which was doing ocean mapping. So going into nearshore waters, I learned that term, nearshore waters, and mapping the ocean floor where it hasn't been mapped. And there is a goal apparently internationally to map the whole ocean by 2030, but at the moment that's not reachable. But anyway, that unmanned surface vessel was really interesting to watch, and we did quite a few different types of stories on that work.
Yeah. Yeah, excellent. And somebody's asked the interesting question of what were the accommodations on board like? Comfort, space, food, etc. So I got to say, that this was actually something that I was quite worried about. I've done lots of work on Coast Guard ships, so I'm quite familiar with what those vessels are like. And I was worried about this because we had some understanding of what our accommodations would be. So for context, we definitely, most of the male scientists were in a room with 20 bunks in it, shared with us and other Navy crew, which is a bit intimidating at first. But it was actually fine. It was not a big deal. We had enough sort of personal space and to be comfortable there, and develop some good camaraderie with those people that were sharing that space with us. So it was something that I was worried about going in, but it turned out to be just fine. And then the food was excellent. I think one thing that struck me, Susan, I don't know if this struck you as well, on this class of vessel, there's really just one eating space. So all of the officers and all of the lower ranking crew and all of the scientists, we all eat together in the same space. And that's not always the case on other vessels. There's often, different spaces for officers and other crew members to eat. But I think it created a really nice sense of camaraderie. And, I think that really goes a long way in terms of comfort. But I will ask Susan to answer that question too, because her accommodations were a little bit different than ours.
Yeah, I felt most badly for my camera operator, videographer, because he was working night and day, and he had to sleep in a storage closet. Literally, you can imagine a single cot, not a bed, not a bunk, a cot. And he could reach out and touch the storage shelves where they had all kinds of different Navy paraphernalia on them. And I think for all of us, there was a very loud sound of air conditioning or air circulation in the ship. And my producer and I, another female, were sleeping basically next to each other on a cot in a small change room, which used to be used for the airmen who would come on the ship, and they would change in this room. So it was a closet, no windows, nothing. But I can tell you that I have slept in many places in the world, much, much, much more difficult than this. And you get used to anything. And the other thing is, I don't know about you, Brent, I was so tired at the end of the day, I pretty much slept almost every night.
Yeah, that's fair. Yeah, and the fact that there were people sleeping, I forget what they call them, these non-standard locations, just spoke to the fact that the Navy really filled this ship up as completely as they could, and really wanted to accommodate as many people as they could as well. So, I think there's a certain number of people that they need to operate a ship like that, and I think they did their best to fit all of us scientists in, and then found some space for you too, which is awesome.
Just in the interest of time, we just have one last question in the chat, and then we'll have to wrap up.
Yep.
The question is, if possible, to explain more about the deep sediment in pipes of 1.5 meter long. What do you expect to get from those samples?
This is a person after my heart. I asked the same question.
And of course, we don't have the right scientist on the call to answer that, but I'll do my best. The crew that's collecting that is from NRCan. Well, there's a few people interested in it, but Alex Normando at NRCan is one of the people that's most interested in that. And I know Alex is most interested in understanding subsurface geohazards, like basically underwater landslides and stuff like that. So they'll be looking at the sort of the sediment grain size and structure and things like that, and trying to understand how sediment moves around on the seafloor. But kind of like the CTD Rosette, and anytime you're out on an oceanographic vessel, if you can collect a sample, whether it's water or sediment, there's always going to be other people that are interested in getting like a little bit of that mud or a little bit of that water, and then using that to look at contaminants or carbon storage or things like that. So I think there's a few other groups that were interested in work that they can do off of those cores as well. But yeah, if you're really interested in more, we are hoping to have a session at the ArcticNet meeting in Calgary in December, and we could hopefully provide a bit more explanation to the entire community about what exactly we did on the science side of things. I'll stop there.
I think we're almost out of time.
Yeah, we'll throw it back to
that brings us to time. So I just wanted to leave with one last thought. But on the topic of research, we just wanted to flag this opportunity for the individuals who have attended this webinar. MEOPAR is in the process of conducting a survey to determine research priorities. We're doing this in collaboration with CCA. So you have an opportunity to lend your voice if you want to scan the QR code, or Marina has just popped the link into the chat as we're discussing about future research priorities with Susan and Brent on this webinar. We're also contributing to a much larger conversation around this. So please lend your voice. We'd be thrilled to have you participate in that survey. It takes about 7 minutes to complete. And with that, I want to say a huge thank you to both Susan and Brent for making your time available for us today. It's been very informative. I know I'll definitely be looking for those CBC shorts, and I hope that others take the time to follow up and to see more about the Antarctic expedition. We also have some stories on the MEOPAR website, which were popped in at the beginning of the chat. So if you want to learn more about the expedition, there are some resources there. Thank you all for joining.